And our first speaker is Marianna Muszynska, and we will hear about the use of VR and psychophysical measures to test the flexibility of embodied cognition in ADHD children.
Okay. Thank you very much. It's just people arriving. Thank you so much for an introduction. So my name is Marianna Muszynska. I'm from Physical Cognition Lab at Center for Brain and Cognitive Development from Birkbeck University of London. And as mentioned, I'll present a paper using virtual reality and psychophysics to test embodied cognitive flexibility in children with ADHD. So let's start with a short overview of ADHD, which is attention deficit hyperactivity disorder. It's a neurodevelopmental condition mainly characterized by differences in attention, levels of kinematic activity, and impulsivity. It's also characterized by a high individual variability in developmental trajectories, with main differences being in functional skills. Traditional methods in studying ADHD involve standardized tasks that are sedentary, accompanied by parental or teaching questionnaires. They mainly look at differences between the control group and ADHD children, and all that tends to overlook the aspect of embodied cognition and then somewhat neglects the complexity of ADHD. Some studies already started responding to limitations, implementing embodied paradigms. Virtual reality is a powerful tool due to its flexibility. It offers rigid controlled testing in an embodied environment. However, the majority of those virtual reality paradigms underutilize what VR has to offer and focus on experiments that don't capture moment-to-moment motor behavior or focus on interventions to ADHD. Our response to those limitations is LEAVES study, and LEAVES means learning, exercise, and adaptability in virtual environments. Okay, so what we did in LEAVES, we introduced psychophysics approach, traditionally used to measure properties of stimuli and how different people perceive that stimuli. When it comes to cognition, in the context of cognition, psychophysics can act as a detection tool of noticeable differences between two states. And in LEAVES, we add a physical aspect to test how children respond physically to the stimuli. And as I mentioned, this aspect is currently underutilized in testing embodied cognition. LEAVES is part of a larger study that involves additional virtual reality tasks, FNIS, resting state measurements, and cognitive tasks. But our paper focuses only on LEAVES task, and I will not talk about the rest of that setup. Hopefully that worked. Yeah, brilliant. This is a child participating in LEAVES study. As you see in that video, they move their body to catch those falling objects. Just leave it for a minute. Okay. So children's task is to catch the objects with their whole body, as you saw in that video. And the targets are either shape-based targets or color-based targets. And the experimenter monitors the child on the screen and gives cues. Either object, children catch leaves and mushrooms, or color, they catch red and blue. And just to recap what we mean by catching objects, children must run between these target landing spots, just like in that video we saw. And we give them VR 3D glasses with motion tracking to track their position. And by tracking the locations of the target object, we ensure that children keep running, as this task's main goal is to promote physical exertion. We use computer vision algorithm, Python MediaPipe, to detect children's body position. The detected children's foot position in each video frame. Each trial had designated target landing spot. white boxes on that photo, and if the child position overlapped with the correct landing spot within 1.5 seconds of the object falling, the trial was scored as successful. In the LEAF study, we tested 19 children with diagnosed ADHD, and in addition, their parents filled in very well-established ADHD characteristics questionnaire, and then we used raw ADHD scores from this questionnaire. Children completed short training session, 20 trials of falling objects with steady speed. Once familiarized, they completed 100 trials, of which 32 trials were switch trials, where the stimulus changed from either object or color or vice versa. And psychometric functions are rich and can give us many measures. We had a look at two strong measures. One is the slope of the function, which indicates consistency, meaning how steady the performance was. And the second is point of subject equality, which is an estimation of how good they were in that task. So yeah, to that end, we took the psychometric approach. And this is the psychometric function for the LEAF task, showing the success ratio in which children succeed to get to the right landing spot, meaning that they were able to run to the correct object. And as a function of how long the object was falling, we expect that when the object is falling for longer, children succeed more. And in LEAFs, we have two functions, one for no switch trials, and that is here in red, and the second, switch trials here in blue. And for each of these trial types, we can get how consistent children were and how successful. And again, we get, for these two trials, we also get the differences between the two types of trials, which indicate how much they were able to switch. It gives us switch information about the consistency and the success in embodied cognitive flexibility task. And we generated psychometric functions for each participant in our dataset and examine how those measures from the psychometric functions are related to the ADHD characteristic scores from the parental questionnaire. For each participant, we got those two measures, consistency in embodied cognitive flexibility and success in embodied cognitive flexibility. And we found two correlations. Children's inattention scores correlated to their consistency in the LEAF's task, meaning the difference between switch and non-switch trials in slope. And we found that children's impulsivity scores correlated to their success in the LEAF's task, meaning the difference between switch and non-switch trials in a point of subject equality. This paper particularly focused on binary outcomes, success or failure. However, we plan to analyze kinematic measures, movement trajectories, and moment-to-moment shifts in running directions. And we also plan to collect data from non-ADHD children and also run the task on the screen without virtual reality for comparison. And I would like to thank you for your attention and everyone who was involved in this project for the help and mentoring. Thank you.
So, thank you, Marianna, for this exciting talk. There's time for questions. I see one up there.
Hi, really, really interesting stuff. So I was just wondering how you saw this finding with respect to the literature on event rate in ADHD. So Edmund Sanuga-Bark did lots of kind of experiments, kind of depending on the rate at which you present the stimuli to participants with ADHD. You don't get atypicalities if you present the stimuli with a long spacing in between, but you do get atypicalities when the stimuli start to come closer together, suggesting that there's some kind of slow varying kind of arousal measure independent of the kind of impulse control that is kind of leading to the atypicalities. And also I wondered kind of what your predictions were for the motor kinematics part of it. So Sorry, 2 questions.
Yep, thank you so much for the question. We didn't analyze the kinematics yet. However, based on ADHD current research, I would predict that there's going to be a high individual variability in their kinematics, but also to the response to the stimuli. And I think based on this task at the moment, there is a huge individual variability in how they respond. So yeah, we'll see how it goes when we do analyze those kinematic measures.
So, other questions? I don't see any at the moment. I hope I haven't overlooked someone. There's another question. Okay, thank you.
Thank you very much for your great talk. And can you show again the result of the individual? The result, if I understand correctly, that most children show the higher performances in a switching condition, the blue lines. Not this one, but they're like a 19, 15 or 19,
it's just very slow.
Independent graph. And then the blue lines shows the higher performances than the red one.
Mm-hmm. This one? Or you wanted to see the for each individual?
Yeah, for each individual. And
there you go.
The blue lines is higher than the red one, suggesting that the switching condition was easier for children.
Yep.
Why?
I think, again, based on just ADHD, it could be linked to impulsivity, that they just respond to the stimulus quicker, basically. That's why they were able to switch quicker.
But the switching is generally the more difficult than non-switching.
Yep.
So even if they have like a trait for their more hyper adaptability, but still their non-switching must be easier.
Yeah, I agree. I agree that it must be easier. But I think this is why it's interesting that they actually were successful in switching, and this is a group of ADHD children. So yeah, I agree with you that this non-switch trials should be easier. So yeah, I'm not sure. So I don't have an answer to your question, but
okay.
I find it interesting too.
Thank you.
Thank you. We have time for one more question. Very short.
Just following on from what was just said, my understanding is that the switch was not in competition, was it? You either got a shape or a color, but it's not like you had to suddenly step back. It's not like the Wisconsin card sort. So that could also be a good reason for why actually the switch could be easier if you have ADHD, because it's a vigilance. You're constantly monitoring the situation maybe, and it's not competition. Do you think that might be something?
Yeah, definitely. Yeah, because you don't step back. You just continue. It's a continuous task. Yeah.
Yeah, it's really interesting work. Thank you, Marianne.
Okay. Thank you, Marianna.
Thank you.